Welcome to another video. Let's solve this equation that says x added to 3 times its fractional part is equal to 11. Now, if you take your time and guess and try some numbers, I am sure you will get at least one of the answers. And just as a bonus, assuming it's an integer, if x is an integer, it means it has no decimal or fractional part. That means this has to be 11. You see that? 11 plus 0 is 11. So you got one answer. But actually, we got more than one answer. And we don't want to do trial and error. Let's just solve it like we have learned over time to solve it. The only problem is we may not know what the definition of the fractional part of a number is. And that's what I'm going to explain briefly. And then we just jump into the video. So the first thing I'm going to do is show you that by definition, x is always divided into two parts. It is divided into the floor. If x is an integer, then x is its own floor and you're done. But if it's not an integer, there's always a part of it that you have moved from the left, you're moving to the right by how much? That is the fractional part. So x is equal to the floor of x plus its fractional part. So take the number 2.3 for example. 2.3 can be written as the floor of 2.3 added to the fractional part of 2.3. We know that the floor of 2.3 is the integer that is less than or equal to 2.3. What integer is that? The integer that is less than or equal to the one just before 2.3, it's 2, right? And this, we'll go back to the definition again. If you now want to find this part, all you have to do is subtract this number from this number. What would you get? You get 0.3. Now, you're going to say, that is so obvious. Why is he saying all these things? Well, it's going to get tricky because what if I gave you negative 2.3? What is the fractional part of negative 2.3? Yeah, that's why you always have to follow the convention of the definition. So let's go back again. What is the floor of 2.3? Remember, we can write this as the floor of negative 2.3 plus the fractional part of negative 2.3. So now we want to find this, right? And we know this is negative 2.3. What is the floor of negative 2.3? It is not negative 2 because negative 2 is on this side. So it is negative 3. It is the integer that you get to the left of negative 2.3. So that's going to be equal to negative 3. So it's negative 3 that you're going to subtract from negative 2.3. So it's negative 2.3 minus negative 3, which is negative 2.3 plus 3. What's that? 0.7. So 0.7 is what you put here. This is, oh no, just 0.7. So this is the fractional part of this number. Yeah, I know. But at least you see how it works now. So generally, this is the definition. X is equal to the floor of x plus the fractional part of x. And remember, you always go in this direction. Your floor is always to the left of x. Okay, I think this is done. So this rule is true whether x is positive or negative. It does not matter. Just stick to it and know what's going to happen. Okay, now let's get into the video. So what should we do first? Based on past experiences, it is just easier to work with the floor of a number than the fractional part or the ceiling. So I would rather rewrite this expression to show me something in terms of the floor, and then I can go back to my k. You remember all the k stuff I've done? That's what I want to do here. So what we're going to do is say that this can be written as x plus 3 times. Now the general definition of this will now be x minus the floor of x. You see that? So if I distribute, I got x plus 3x minus 3 times the floor of x is equal to 11. So this equation can be rewritten as 4x minus 3 times the floor of x is equal to 11. So what does that tell me? It tells me that if I isolate, well, let's come back to the definition, the floor of x. So we're going to say, let's go. Let k be equal to the floor of x. And this means that k is less than or equal to x, and x is less than k plus 1. We know this. So this is something you will always use every time you solve a floor equation. Remember, this is the definition, and this is the relationship it has with x. So the next thing we want to do is let's isolate x here. Okay? So from here, let's go here. So from here, we can say that 4x minus 3k. Remember we said let k be this guy. So this is equal to 11. And if you make x the subject, you're going to end up with x. Let's write it here. X will now be equal to, so let's write 4x is equal to 11 plus 3k. So that x is 11 plus 3k divided by 4. 11 plus 3k divided by 4. And with this, you just need to connect this to this equation that I boxed, and you'll get all the answers that you need to get. It's not that complicated. So let's go. Now we have written x in terms of k. We're going to come back here and say, therefore, we know that k is less than or equal to 11 plus 3k over x, and it's less than k plus 1. So we have replaced x with this equation. Let's split this in two. What do we do here? Let's isolate this part first. Or let's multiply it, no, over 4. Come on, not x. Hey, come on, it's 4. So let's multiply everything by 4. We're going to get 4k is less than or equal to 11 plus 3k, and it's less than, this is going to be 4k plus 4. Now, let's take these two and solve and see what we get. We know that 4k is less than or equal to 11 plus 3k. That means if we move 3k here, we're going to have 4k minus 3k is less than or equal to 11. So that k is less than or equal to 11. So all the integers that we're looking for to make this equation true are less than or equal to 11. Now, let's go to the other side here and see if we can solve it. So let's box this. Now we have 11 plus 3k is strictly less than 4k plus 4. I'm going to bring this here and bring this here. So I have 11 minus 4 is less than 4k minus 3k. Seven is less than k. The train is yelling at me. 7 is less than k, and k is less than or equal to 11. That's just beautiful. Okay, so we have 7 is less than any k we're looking for, and this k is less than or equal to 11, which means all the k's we're looking for are, if 7 is less than an integer, it means that integer has to be 8 or 9 or 10 or 11. So here k is equal to one of these. K is in the set of 8, 9, 10, 11. So we're almost there. Our mission now is to find all values of x that satisfy this equation, and we already said that this is what x is. X is 11 plus 3k divided by 4. So option 1, x 1 will be equal to 11 plus 3 times 8 divided by 4, which is 3 times 8 is 24. 24 plus 11 is, what's that? 24 plus 11 is 35. 35 divided by 4 is going to be 8, 3 over 4. That's 8.75. That's our answer. 8.75. I know it's correct. Let's go to the next one. X2 will be equal to 11 plus 3 times 9 divided by 4. 3 times 9 is 27. 27 plus 11 is 38. 38 divided by 4, that's 36, remainder 2. That's going to be 9.5. 9. Wow, 9.5? 9. Oh, that's true. That's equal to 9.5. Nice. X3, we have 10. So it's going to be 11 plus 3 times 10 divided by 4. So this is going to be 30 plus 11, that's 41. 41 over 4 is going to be 10.25. 10.25. Nice. And X4 is going to be 11 plus 3 times 11 over 4. This is 33 plus 11, that's 44 divided by 4, that's 11. So as you can see, this was the one we guessed at, not guessed, we figured out at the beginning that if there is no fractional part, then this is going to be 11. And these are the other options that you have. Never stop learning. Those who stop learning, stop living. Bye-bye.